It's almost impossible to imagine life without chemistry, but let's try. What if instead of molecules reacting and transforming, life relied on something entirely different? On Earth, everything that lives depends on catalysis, enzymes and surfaces that speed up chemical reactions, letting cells build, break down, and recycle materials efficiently. Without catalysis, even the simplest reactions would take thousands or millions of years. So, could life exist in a universe where chemistry barely happens? The answer depends on how we define life. If life means a system that stores information, adapts, and uses energy to maintain order, then maybe. But it would have to be based on physics, not chemistry. Imagine a world where living systems are patterns of energy and information, not molecules. They could operate more like plasma structures in stars, vortices in fluids, or self-organizing electromagnetic fields that store and transfer information without any atoms exchanging electrons. Could such entities evolve? Possibly. If fluctuations in energy could replicate, compete, and improve. Some physicists even speculate about life in neutron stars or magnetospheres, where stable magnetic or plasma loops could behave like cells, growing and splitting through field dynamics rather than biochemistry. It's alien, yes, but conceptually similar. A pattern that sustains itself far from equilibrium by processing energy. Still, our familiar biology reminds us how crucial catalysis is. On Earth, every heartbeat, thought, and breath depends on enzymes, nature's nanomachines that speed up life's chemistry by a trillion-fold. Without them, food wouldn't metabolize, DNA wouldn't copy, and cells couldn't repair themselves. So, if life ever existed without chemistry, it would be slow, ghost-like, and probably invisible to us. More a pattern of energy flow than a tangible organism. Perhaps in some distant corner of the universe, such systems already hum quietly, living not through reactions, but through resonance.
Can life exist without chemical reactions? Let's explore radical alternatives to chemistry-based life. Instead of molecules and reactions, imagine life built purely from fields, forces, and patterns in physical systems. First, we need to understand what life requires if chemistry is completely removed from the equation. Life fundamentally requires localized structures that maintain themselves far from thermodynamic equilibrium by processing energy and information. These structures must channel energy flows from high to low gradients, maintaining order against the natural tendency toward disorder. Without chemical reactions, metabolism becomes the controlled channeling of energy through physical gradients and field discontinuities. Genetic information cannot be stored in DNA sequences, but instead must exist as reproducible patterns in fields or mechanical configurations. A pattern of alternating field states acts like a barcode that can be read and copied, serving as hereditary information. Think of a music box to understand how purely physical systems can encode and reproduce information. A music box encodes melodies and gear patterns, not chemistry. As long as you wind it with energy, it reproduces the same tune reliably. The arrangement of pins on the cylinder stores information, and mechanical coupling reproduces this pattern as sound when energy is supplied. Our first concrete example uses light itself as the substrate for lifelike behavior. Non-linear optical media support solitons and cavity modes that behave like stable particles with logic-like interactions. In driven dissipative cavities, standing wave patterns can be precisely written, moved, and erased through controlled optical pumping and feedback. Information is encoded in the phase relationships, polarization states, or occupation numbers of optical modes rather than in molecular bonds. Coupled optical cavities can transfer patterns through stimulated emission, much like DNA replication copies genetic information. Asymmetric quality factors in gain profiles rectify photon flux, creating directed energy flow that powers pattern maintenance. Competition between different optical modes implements natural selection, favoring patterns that channel pump power most efficiently. Imagine a hall of mirrors where light arrangements persist and proliferate by continuously drawing energy from lamps. Like a hall of mirrors creates persistent light patterns through reflections, photonic systems maintain stable configurations through field interactions. Plasmas offer another substrate, using electric fields and charged particles instead of light. Plasmas naturally form filaments, double layers, and sheaths that act like membranes and channels, separating charge and potential. Plasma double layers naturally rectify the flow of charged particles, implementing valve-like behavior without any molecular machinery. Filament networks in plasmas can branch, merge, and reconfigure their topology, providing analogs of growth and morphological change. A plasma filament can split into two stable daughter structures under the right field conditions, analogous to cell division. Instead of metabolizing glucose or ATP, these structures maintain themselves through continuous input of electric field energy. Lightning channels provide an intuitive analogy for how plasmas self-organize into stable, reproducing structures. Lightning branches and stabilizes along preferred conductive paths, just as plasma filaments organize into stable configurations under sustained fields. Let's summarize the essential requirements for life without chemistry to function. Cell boundaries must arise from electromagnetic field discontinuities, interfaces, or topological defects rather than lipid bilayers. Reproduction must copy spatial or temporal patterns through field coupling or mechanical templating, not through adding molecular building blocks. Hereditary variation originates from noise in energy flows, field fluctuations, or particle collisions rather than errors in copying DNA sequences. Apparent pattern produces copies, and noise occasionally introduces variants that may be selected if they dissipate energy more stably. Natural selection operates on these physical structures, favoring configurations that dissipate input energy stably while preserving their characteristic patterns. We've seen that purely physical processes can, in principle, support all the hallmarks of living systems. Photonic systems using nonlinear optics can maintain heritable patterns that reproduce through stimulated emission and mode coupling. Plasma double layers and filaments create boundary structures and directed flows analogous to cell membranes and metabolism. The key insight is that electromagnetic fields, mechanical forces, and reproducible spatial patterns can play all the functional roles filled by chemistry in conventional life. These examples show that life is not fundamentally about chemistry, but about maintaining dissipative structures that process energy and information through reproducible patterns. Explore how lifelike behaviors emerge from physics and computation without chemistry. Lifelike properties can emerge from purely physical systems, including topological defects, mechanical automata, and computational patterns. Topological defects in magnets and crystals behave like robust, particle-like entities that can replicate. A skyrmion is a swirling, magnetic configuration that acts like a stable particle within a spin lattice. These topological defects are incredibly robust, behaving like particles that resist disruption. External magnetic or electric fields can create, move, and even duplicate these defects. A current pulse can push a replication front that copies the skyrmion pattern into adjacent regions. Topological protection makes these structures naturally resistant to errors, providing stable memory. A skyrmion lattice can clone its entire pattern when driven by carefully tuned current pulses. Moving and bouncing bodies can implement computation and replication without any chemistry. Vibrating grains or rotating gears can process information through collision rules, creating mechanical computation. Bouncing bodies can implement logical operations purely through their physical interactions. A propagating front can copy mechanical orientations, like dominoes falling in a specific pattern. Vibrated rod assemblies can spontaneously form traveling swarms that seed new swarms with identical properties. Steady vibration provides energy, while metastable packing configurations store memory. Simple geometry plus sustained drive can create computation without molecules or electronics. Abstract cellular automata replace chemistry with simple update rules on discrete states. Cellular automata use simple local rules to update cell states, creating complex emergent behaviors. These systems produce gliders that move, oscillators that cycle, and structures that replicate themselves. Self-replicating loops can copy themselves and spread across the lattice, colonizing empty space. Simple local rules can give rise to universal computation, proving any algorithm can emerge. Energy flow maps to clock ticks, while dissipation occurs through bit erasures governed by fundamental physics. All three systems share fundamental principles that enable lifelike behavior. Memory, replication, and selection all emerge when energy flows through structured systems. Thermal noise and disorder introduce variation, while physical structure enables selection of stable patterns. Energy drive plus physical structure plus noise can create evolutionary dynamics without biology. The fundamental insight is that lifelike properties transcend chemistry. Memory, replication, and selection can emerge purely from physical laws and information processing. These systems demonstrate lifelike behavior without any molecules, enzymes, or traditional catalysts. Physical systems can exhibit the core properties of life through topology, mechanics, and computation. The same evolutionary patterns appear whether the substrate is magnetic, mechanical, or computational. Life equals physics, plus information processing, plus controlled dissipation of energy. Exploring how lifelike properties can emerge from pure physics without any chemical reactions. Imagine self-organizing patterns that maintain themselves purely through energy flow, like whirlpools that persist without any chemistry. First, let's understand how physical systems can perform work and maintain themselves without chemical reactions. Traditional metabolism relies on chemical reactions, but physical systems can achieve similar results using pure energy flows. Physical rectifiers can convert random energy fluxes into organized motion, just like a diode converts alternating current to direct current. Key mechanisms include asymmetric potentials that favor one direction, diode-like transport that blocks reverse flow, and feedback control that adjusts the system. Random energy gets converted into useful work through these physical rectification mechanisms. Homeostasis works through sensors that detect environmental changes, controllers that compute responses, and actuators that adjust system parameters. For example, an optical pattern can stabilize itself by automatically shifting its pump phase whenever a sensor cavity begins to detune from resonance. Now let's explore how heredity and evolution can occur in purely physical systems without any genetic molecules. Heredity in physical systems uses spatial or temporal patterns as templates that can be copied through front propagation or mode seeding. Physical patterns can replicate through mechanisms like front propagation, where a wave pattern spawns new waves, or defect cloning, where structural features reproduce themselves. Like DNA replication, pattern copying introduces errors determined by noise levels, coupling strength, and encoding redundancy. Recombination happens when patterns fuse or interfere, creating hybrid patterns that may outcompete their parents, just like genetic crossover. Fitness in physical systems is defined by how efficiently patterns capture throughput, maintain stability, and grab resources under environmental conditions. For instance, two competing optical mode patterns can hybridize into a new stable beat pattern that outcompetes both original parent patterns. How would we actually test whether a physical system exhibits lifelike properties? What evidence would be convincing? Laboratory experiments should search for self-maintaining, self-copying patterns in non-chemical platforms under constant energy drive. Key metrics include how long patterns persist, how accurately they copy themselves, how much information they encode, and how much energy they dissipate per copied bit. Convincing evidence requires demonstrating self-maintenance, heredity through pattern copying, and evolution through heritable variation. Scaling studies must show that larger organisms emerge from modular copies, not from external programming or human intervention. The strongest possible evidence would be open-ended novelty, where new unprogrammed functionalities emerge and remain stable under perturbation. Imagine a photonic cavity array that spontaneously invents a new timing code to avoid interference, then spreads this innovation across the entire array. Let's summarize the key concepts of how physical systems can exhibit lifelike properties. Physical life requires three core capabilities: converting energy into work, copying patterns with heredity, and evolving through variation and selection. Metabolism becomes a process of energy rectification and feedback control rather than chemical reactions. Heredity becomes pattern copying, where fidelity is limited by noise rather than by molecular transcription errors. Evolution becomes drift through attractor landscapes, where patterns that best exploit environmental drives are naturally selected. This framework suggests that life is not fundamentally about chemistry, but about self-organizing patterns that maintain, copy, and evolve themselves using energy flows. The profound implication is that life might exist in many different physical substrates beyond biochemistry, anywhere patterns can self-organize under energy flow.